Welcome 8th graders to Learning Target. I can determine if numbers are rational or irrational. You'll also hear this sometimes called I can classify numbers as rational or irrational. And also you're going to be asked to name all sets to which a number belongs. And that's falling under those same categories. Remember to pause when you need to and take some good notes. Write down some questions that you have. So we're going to look at this kind of flow chart here to help us guide through what is what. So we're going to first talk about, we're going to be looking at all numbers. All numbers, under all numbers falls real, and then also is non-real numbers. We aren't going to focus on those, but know that that is a thing. They're also called imaginary numbers. So we're going to look at all numbers, real numbers, and under that is rational and irrational numbers. Rational numbers, you've heard before, are numbers that can be written as a fraction. So any number that can be written as a fraction is rational. It's also decimals that terminate. And what does that mean? Decimals that terminate, that means that they stop. Think about the terminator. Stop. So 0.12, it stops at the 2 in the hundredths place. Also, decimals that repeat are considered to be rational. So that would be like 0.3 repeating, where that bar notation shows that it's repeating. So rational numbers are numbers that can be written as a fraction. Another definition would be irrational numbers. Irrational numbers are numbers that cannot be written as fractions. They cannot be fractions. They would also be decimals that do not, two words, do not terminate, meaning they don't stop. So a number like pi, where it's 3.14159 ... and it doesn't repeat, but it also keeps going. So it also, they do not repeat. So, 0.3 repeating would continue, but a number like this, where the dots keep going, but there's no repeat again. So it does not terminate, and it does not repeat. So numbers that cannot be written as fractions, numbers that can be written as fractions. Under each one, there's nothing under irrational. If it's irrational, you stop there. Rational numbers, after that, they could be considered to be integers, which are your 0, 1, 2, 3, and so on in whole numbers, and your negative numbers. So I like to describe integers as whole numbers and their opposites, Because integers, then we continue from there. If a number is an integer, then it could also be a whole number. Whole numbers are your 0, 1, 2, 3, and so on. Numbers that you can count by and go up and go from there. If a number is a whole number, you might want to consider to see if it is also a natural number. Natural numbers are your whole numbers that you can actually visibly see, I would say. So it's all those whole numbers, but not including 0. I always remember whole has a 0 in it, has an O in it. Okay, so we're going to work on classifying, knowing this. So here's another way to organize. Remember, pausing is always a good choice as well. This is another way to organize what kind of numbers fit. So if I just put some numbers up here, let's say 0. It's kind of tough to write with this pen. Okay, ignore that. 0.412, negative 3.6. Let's just start with those two. So maybe if I decide, okay, where does negative 3.6 fit? Is it rational or irrational? Well, this has a decimal that seems to terminate or stop there, so it's rational. Just because it has a negative there does not mean that it's an integer. Because it has that fraction portion, it's not the opposite of a whole number. It is just rational. Another example, this decimal terminates. It stops there, making it a rational number. Examples of irrational numbers, decimals that do not terminate, so those dots continue. Pi would be irrational. Okay, the square root of a non-perfect square. Okay. Another rational numbers again, so I could put a fraction over here. It's rational. Say I asked you about the number -2. -2, can I write -2 as a fraction? Yes, that means it's rational. But is -2 an integer as well? Yes, it's the opposite of the whole number 2. So -2 would fall in the integer category. But what if I said the number 2? 2 is rational. I can write it as a fraction. 2 is an integer as well, and it's also a whole number. 2 is a whole number, but that means it's also actually a natural number if it's there. A number that would fit in whole and only stay in whole and get past there would be 0 because it doesn't fit as a natural number. So keep those in mind. You want to kind of go down the list and decide yes or no. All right, so classifying numbers. You may be asked to classify numbers and decide where they belong. So again, you want to start as kind of like a checklist. You always decide they're going to be real numbers. For now, we're going to look at real numbers mostly. If they're real, you decide, is it rational or irrational? So remember, can I write it as a fraction? Or can I not write it as a fraction? Pretty much the deciding factors. Integers, remember, are your negatives, 0, and your positives, and so on. Obviously, the included numbers. Your whole numbers are 0 and your counting number positives. Your natural numbers are your counting number positives, not including 0. So when you're asked to decide what it belongs to, if you look here, the square root of 81, square root of 81 is actually the same as 9. So I decide, okay, is 9 rational? Well, it's a real number. Is it rational or irrational? 9 can be written as a fraction. I could write as 9 over 1. So yes, it's rational. Is 9 an integer? Does it fit in the category of a whole number and its opposite? Yes, it's a whole number, so it's also an integer. It is a whole number. I can count by it. And it also is a natural number. So that's the set to which it belongs. Square root of 56, if you plug that into your calculator, you're going to know, maybe you don't have a calculator, you're going to know that that is between the square root of 49 and the square root of 64. So it's between 7 and 8. But it's going to be a decimal that continues without repeating, so it does not terminate and it does not repeat. This would be an irrational number. And then you're done. If you know it's irrational, you're done in the sets. Negative 52 and a half. So we see 1/2. I know I can write that as negative 52 and 1/2. It can be written as a fraction, so it is rational. Even though it's a negative, it's not an integer because of that fraction part. It's not the opposite of a whole number, so it's just stopping at rational. Here we see a decimal. Right away you might want to say, oh, it's irrational. It has a lot of numbers. But notice it stops. There's not that dot. It terminates right there, making that a rational number. Turn fractions into standard form, so just number form, then name all the sets to which it belongs. That's what I was talking about. Name all the sets to which a number belongs. That means we want to start at the top. We want to say starting at real, and then deciding if it's irrational, rational, is it an integer, whole number, and a natural number. So we got to simplify first, make standard form. 12 over 2 is the same as 6. Well, 6 obviously can be written as a fraction, so 6 is real, first of all. It is rational. 6 is an integer. 6 is a whole number. And 6 is a natural number. Below I have 5 over 22. If you put that into your calculator, comes out 0.222727 and so on, where you start to see that 2, 7 repeats. So when you see that, you say, oh, it does repeat. Repeating decimals can be written as fractions. So this is a real number, and it is rational because it can be written as a fraction, which you already saw, and therefore it stops at rational because it is no longer an integer. One thing to keep in mind, whole numbers, kind of deciding, if you can get to a whole number, you obviously have to go through all the other categories. So if you think -4, is that an integer, a whole number, or is it the both category? So this -4, think, can be written as a fraction. The negative makes it an integer. The negative makes it not a whole number. So that just fits here. 10 is an integer, but it's also a whole number, so that's going to fit in the both. -15 is just an integer. Negative numbers are only integers, not whole numbers. 5 would be both. And then this negative and 2700, or 3 and -2700, 3 and 2700ths, excuse me, it is a decimal, which means it doesn't actually get past the rational part. This is just a rational number. A lot of information wrapped up into one there. Rewatch when you need to. Pause when you need to. Make sure you're writing down questions that you have. It's very important that you ask questions. See you soon.